Hi everyone, my name is Hila Manol, and I will present today our work spanning the visual analogy space with the weight basis of LoRAs. Diffusion and flow models have become very powerful and widespread tools for text-based image generation and editing. However, editing images using only textual instructions is quite limited, as many visual transformations are inherently difficult to articulate precisely through text alone. For example, consider this pair of before and after images of a man. Supposedly, to apply the same transformation between the two images to a new image, we would just specify to add a hat. But actually, this doesn't capture everything that the image pair at the top can tell us, like how is the hat placed or how the zoom has changed. Describing all of that in text becomes more and more complicated. The task of image analogies attempts to solve that ambiguity by providing the triplet of input images, which allows inferring the full transformation from the images. Recent works leverage foundation models by adapting them to the visual analogy task using a single low-rank adaptation module. For example, we can add some rank R LoRA to a conditioned flow model and train it on a composite input image of the triplet input images. While effective, these methods face a fundamental limitation. They attempt to capture the diverse space of possible transformations within a single adaptation module, which can limit the model's ability to generalize across the rich variety of relationships that exist in images. A naive solution would be to specialize the model to each specific analogy task at inference time by using hypernetworks. Unfortunately, hypernetworks are notoriously difficult to train. Instead, we draw inspiration from a recent work that demonstrated that independently fine-tuned LoRAs for face personalization can form an interpretable weight space. They showed that if you train 65,000 LoRAs, one for each person in your dataset, you can construct a weight space of faces, where the LoRAs act as a basis of semantic visual traits, like age or gender, and interpolating between the LoRAs can cover new faces in this space. However, can this idea be transferred to image analogies? A basis for the constrained domain of face image personalization took 65,000 LoRAs. Apart from the expensive compute needed, gathering such a large training set of varied analogy pairs is difficult. Instead, we propose LoRWeB, which learns how to dynamically combine LoRAs from a learned basis at inference time. In LoRWeB, we first take our input triplet, A and A prime, that describe a visual transformation, and B, which should be edited analogously, and encode it with clip and a small projection module. The similarity between the encoded vector and a set of learned keys determines linear coefficients. These linear coefficients are used to combine the matching learned LoRA basis vectors into a single mixed LoRA. The mixed LoRA is injected into a conditional flow model like flux context. The flow model gets a 2x2 composite image from the triplet and learns to produce a composite image with the edited results B' in the bottom right quadrant. Importantly, a single rank R LoRA is a special case of LoRWeB for the same capacity, and a simple rank R LoRA is just a single point in the space of all rank R LoRAs which LoRWeB aims to span. Using our method, LoRWeB generalizes to a wide variety of new analogy tasks, from object addition, like the flower crown of the cat to the dog, to transferring specific styles, such as the comic book bursty pop art style of the bird to the cat, or pose changes. When compared to previous approaches, LoRWeB better maintains the visual details of both the subject and the analogy itself, for example, keeping the identity of the cat the same and adding the exact same jeweled crown. Finally, we evaluate LoRWeB quantitatively and show our method outperforms state-of-the-art image analogy approaches, both in terms of transformation accuracy and in terms of preserving the content of the edited image. We also conduct a user study and show users preferred our edits over all compared approaches. You can check out our project webpage and paper for more results and in-depth discussions. Thanks for listening, and I'll be waiting for you at the poster session.